Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, step 2, step 3, and your challenge is, in this case, to predict the number of red boxes in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of red boxes in any step at all? So that's the challenge. If you'd like to accept that, pause the video, give it a shot. All right, so this is an odd one, right? Because we've got this sort of grid of squares, but we're really only counting the red ones. And I think this grid is to give us a hand because this might be kind of a tricky one. So the number of filled in boxes in step 1 is 0. I'm just going to jot our numbers here. It's 2 here and it's 6 here. It looks like everything but the top row maybe is filled in. Here's the top row, so it's not filled in, and then here's the top row, here's the top row, and then the grids are square grids. They're the step number squared, right? This is a 1 by 1 grid, this is a 2 by 2 grid, this is a 3 by 3 grid. So I would expect we'd have a 4 by 4 grid here, right? And then everything but the top row would be filled in. So we'd have 3 rows of 4 filled in, so that would be 12, and we'd have 1 row not filled in. So my prediction for step 4 is 12. Now, can you tell what kind of a pattern this is going to be? Are there any clues up here that give you an idea about what kind of pattern this is going to be? Let's go ahead and analyze the numbers so we can get some clues that way. So I'll make a chart with a step number and the number of boxes. So in step 1, we've got 0. In step 2, we've got 2. In 3, we've got 6. And in 4, we're predicting 12. So let's take our differences. 2 minus 0 is 2. 6 minus 2 is 4. And 12 minus 6 is 6. So this is not a constant. This is not a linear pattern. Well, let's take our difference of our differences. So 4 minus 2 is 2. And 6 minus 4 is 2. Aha, so we get a constant in that second set of differences, which means this is a quadratic. And maybe the squares gave that away. It's not just plain old x squared. That would be 1 and 4 and 9, and we've got 0 and 2 and 6. But it has something to do with x squared. And when you see this 2 here, this number in the difference of the differences, you just divide that by 2 to get the coefficient of your leading term, your x squared term. That's 1. So our leading term is going to be x squared, which is maybe a little confusing because in each of these we don't have a step number squared. So what I'm going to say is that something is being subtracted. So in each of these steps, so in step 1, we're going to have the step number squared minus something. And well, to get to 0, I'd have to subtract 1. All right, how about in the next one? 2 squared, step number squared minus what? So that'd be 4. I'd have to subtract 2 to get there. How about in this one? 3 squared would be 9, and then I'd have to subtract 3 to get to 6. And look at what we're subtracting. 1, and then 2, and then 3. So we're actually subtracting the step number every time. And we do the same thing here, right? This would be 16 minus 4 to get you to 12. So our equation then is going to be the step number squared minus the step number. So you can think of the minus part as this empty row at the top and the step number squared as the grid. So our equation is y equals x squared minus x. So to calculate now how many in step 43, we're going to have y equals 43 squared minus 43. So 43 squared is 1849. And then we subtract 43 from that, we're going to get 1806. So 1,806 filled in red boxes in step 43. Well, how did that go for you? I think that was kind of a tricky one. When you are subtracting from a square, it can get pretty confusing. Did you get 12 for step 4? I'd be interested to know. Thanks, everybody.